Okay.
Okay. Oh.
Computer's being slow.
Okay.
There we go.
Okay, is everybody ready?
Yeah.
Yeah.
Okay. Daniela, why don't you start us off with the first question?
See, what does it mean to have matched pair data? So I write that is when we involve only one population and a pair of observation is drawn of the individual select for the sample.
Okay.
So yeah, that's this.
So matched pair, like I'm not really sure, where a pair of observations is drawn on the same individuals selected for the same sample, such as, oh, okay, so like somebody, like a test done, but, or trying to think, like a survey done on, if somebody were to ask me a question and then I were to go through an activity and ask me the same question afterwards, my, like what I say would be the matched pair.
Yeah, it's like
Okay.
2 times you obtain data, but the first time is with one strategy, and the second one is with another process. So
Right.
we see.
So you perform 2 experiments and you take a sample from the first one and from the second one, but it's from the same individual.
Yeah.
Cool.
Sometimes, because I think in other example there is 2 different persons, like, but the first one is someone who is health and the second one is like they have the same like
Criteria, same category, same kind of person.
Yeah, but they are different. But we use always similar things in both.
Right.
I think.
Okay.
Yeah.
So it's trying to compare 2 samples, and you have to make the person that you got the sample from close enough that they can be comparable.
Yeah. Yeah.
Okay. So then question 2, what are the differences in the hypothesis test between a one sample T and matched pairs?
There is no difference. I think the only difference is that before we need to subtract. We need to subtract the post and pre-scores before to do the other steps.
Right. To find the difference between the 2.
Mm-hmm.
Okay. And then we can go over question 2. Andrew, you want to read the scenario?
Hold on 1 sec.
Okay.
How's it going?
Good. We're late. Are we okay?
Oh yeah, you're great. Hold on 1 sec. You guys, I gotta go. My bishop's over.
Okay.
Okay.
So I'll get on when we're done.
Okay.
All right. See you guys.
Bye.
Okay, so Daniela, you want to do this one with me then?
Yeah.
Okay, matched pair T procedure. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products, and obtains the following data. He wants to know if the mean assembly time is different and use a level of significance of 0.05. Use the data from that link. Did you do this one already?
Yeah.
Okay, I haven't done it yet, so I'm gonna get all the numbers and put it in the Excel. So factory assembly times. And when we do the difference, we do the pre-assembly change minus the post.
I think it's the post minus the pre.
Okay. I'm glad I asked.
And
Okay, so I think I have it. So now we can answer the questions. Okay, design study. What is the research question?
I think the question is, he wants to know if the mean assembly time is different if he uses another process.
Right. So he wants to see if the new process that he's telling them to use is gonna result in a different time than the old one.
Yeah.
Perfect. Okay. And then state the null and alternative hypothesis. So the null hypothesis is that there's no difference.
The null hypothesis is always 0. Always.
Yeah, exactly. So the null hypothesis is that the mean equals 0. Or like not the mean, but like there's no change in the mean. And then the alternative hypothesis is that the mean time is not 0.
I was confusing that part because I write that my alternative hypothesis was the mean was more, like bigger than 0, but I don't know why in this case it's only different. Because
because it's not, we're not trying to figure out whether the mean, like our question is not what the mean time is, but is if our question is if it's different.
Yeah.
Right.
Yeah.
So it's just if it's different. So when you say the null hypothesis, then you say there's no difference. So the difference equals 0.
Okay.
And then when you say that the difference doesn't equal 0, that's the alternative hypothesis.
Okay. Yeah. See.
Cool.
Thank you.
Okay, then do you want to do question 4?
Yeah. Collect the data. Describe the data collection procedure. So I wrote that he make a simple random sample of his workers and measure the amount of time that his workers spend doing their part in the assembly line with one process, and the same workers with how much time they spend doing another process.
Perfect. So yeah, that's exactly right. And I'm glad that you said that it was that he randomly chose 9 in the beginning, and then he used the same 9.
Yeah.
Yeah. Okay. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. I haven't put this in to a graph. So I'm going to do that right now. Okay. Or did you already do the graph?
Yeah.
Do you want to show me the graph?
I don't know how.
It's on your computer?
Yeah.
Okay, so if you want to move the mouse on the left side, a la izquierda, there's button at the top, and it's a green screen with an arrow. You see that?
No.
So I'll show you. I'll screen share and I'll show you what I'm talking about.
But I think we can. I have the same like I doing the key thing. Maybe.
Right. So look at my screen. It's kind of going crazy right now. But you see up on the left.
Uh-huh.
So if you click that.
Uh-huh.
So click
All
that
right.
one. And then you can show me your graph.
Okay, give me a minute. I need to open my Excel thing. I can't open my. I can find it. Okay, give me. I can watch mine. Okay, it's here, but I don't know if you can.
Oh, and then on the top, there's a button that says "Present to everyone."
Do you? And then I find. Okay. Can you watch now or not?
Yeah, I can see it. Now I can see everything you do.
Yes. Thank.
Yeah.
But I don't know why my graphic is like weird here. Like it's here, but I can't like.
Yeah, that is weird.
Feel. I can't. But I can do it again.
Okay.
It's like this, right?
Yeah. Awesome.
I can't. I want to. Okay, it's that one, right?
Yeah. Okay, perfect. So then the like the description of our numbers, where it says like the first quartile, the mean, the median. Where's that on your table?
The medium and everything.
Yeah.
No sé. I think it is not there. I always, when I do my Instagram thing, I use the other Excel thing. So I'm going to use.
Well, like just the numbers, the 5 descriptive numbers.
It's there in the but this is in the table in the.
Right, in the table, not in the graph.
So the mean is we use the difference.
Right.
So the standard deviation, the mean of the difference, and the standard error of the mean is what we use.
Yep.
Right.
Okay, cool. So then moving on to the question. So describe the data. It's just everything that you were just saying.
Mm-hmm. Yeah, like the mean of the difference and the standard deviation. Mm-hmm.
And then the n is 9. The sample size is 9.
Yeah.
And then, so this is what they provide. This is what it is showing. You can look at my screen now.
Yeah.
And I'm going to show you what the answer key shows. Where is it? It's right here. So it says this is what the histogram should look like.
Like the
Right, and then this is what the two graphs should look like independent. So this is the post-assembly and the pre-assembly.
Oh, I only make the histogram
one
for the difference.
Right, and so that's why yours looks like the way it does.
Oh, okay, yeah.
Okay, cool. And then, so question 6, is that what we're on?
Yeah, question 6, make inferences. What type of hypothesis test is appropriate? So the t-test score?
Right.
It's the same like we learned the last week.
Right. Yeah, the t-test, because we're not comparing it to a general population. We're doing it off of our own population. So that's why we'll use t. That's why we use t instead of z.
Yeah.
Yeah, and then the sample mean of the differences.
Because there are 2 groups of samples, right?
Right. Then compute the differences between the 2 times and determine if the requirements are met for the test.
Are the same requirements, like if the sample mean is large and the data represent a simple random sample from the population. So the first one is the data represent a simple random sample from the population. So
right.
Yeah, and the mean of the difference follows a normal distribution. But I think in this case, it's not a normal. It's not normal.
It might not be. So because the n is less than 30, we have to do a QQ plot in order to see if it's normal. And the one that the answer did, it shows that it might not be normal because there's not enough to tell.
Yeah.
But
the reading says that it's not important. It's not so important about it.
Right.
Yeah.
So then compute the difference. Continue with the test regardless of what you found in part C. Compute the test statistic. So
the test statistic is.
That was it's supposed to be standard deviation.
-1?
Yeah, it's like 1 point something and then minus 1 point something. 1.22 and then minus 1.22. Awesome. And then the degrees of freedom is n
8
minus 1, so it's 8. And then so did you figure out what the p-value is from our test distribution?
The t-distribution applet. Yeah, I have here, I think.
What did you get for the p-value?
What was I going to tell you? Menos 1.220. It's 0.3096. Right?
Are you using the t-distribution or the normal probability?
The student's t probabilities.
Because it should be like 0.257.
So, give me a minute. So, I am confused when we to subrayar, no sé cómo se diga. The Apple settings. Use C or not?
So we don't use Z. We have to figure out what T is.
I am using the T applet distribution.
Yeah.
And I found the area is 0.3096. But if I, how do you say, like subrayar or colorear? Do you know what is that?
Do you hear what she's saying? Say that word again.
Colorear or sombrear.
Shade.
Shade.
Or
Okay,
to color in.
So I need to shade 2 parts, or what parts I need to shade of the T distribution?
It's a good question. But I think I thought it was going to be, what you have to do is make that 9.
Okay.
So did you make the degrees of freedom 8 at the top?
8.
And then you shade the sides, the tails.
2 tails. So the both sides, right?
Right.
So I get 0.25272.
Perfect. That's what it is.
Right.
And then because the p-value is 0.257, that is greater than 0.05.
So we reject the...
So we fail to reject the null hypothesis.
We fail to reject, so there is no difference, right? Too much difference between the process.
Right.
And then, well, this is the conclusion difference.
Sorry, which one are we doing now? We're on H? Yeah, present your conclusions from the English statement. So you already said it. Because the p-value is greater than the a value, we fail to reject the null hypothesis.
Yeah.
Okay. Rather than testing a hypothesis now, say you just wanted to estimate the mean difference between wait times at 95% level, what would you do? Be sure to calculate the margin of error, do it, and paste your results below. What did you do for that one? I'm kind of confused on that one.
You need to use, only you need to copy and paste. You need to copy the difference, the differences, and paste in the one sample t-test.
Right.
And I can pay. You change the, how do you say, the confidence level, and that's it.
So rather than test, is this for, are you talking about 7?
So you use the paired sample t in the paired sample t-test right now. So we only are gonna copy the differences and paste in the one sample t-test.
Right.
And I think that's it. Okay. It's like mine. Oh. But I don't know why I don't send. Come on, save that. That's it. And is what I did. The confidence interval is minus 3.051 and 0.940.
Awesome.
So you only need to copy and paste.
Right. It's either that way or it's from 0.9397 to positive 3.0508. So does that make sense? So you can have both of those. It can either be from the one side or the other side.
All right.
Like either from negative to 0.9397 or from 0.9397 to positive 3.051.
Mm-hmm. We will create. So we need to create an analytical distribution. I think it's depending on the difference, but what I get, according with the book, we only need to copy and paste in the one sample t-test, and this is the confidence. And the only thing that we need to change is the confidence level, but in this time is 95%, right?
Right.
Oh, it's what I get.
Okay. Awesome. And then
It's right.
For the last one, in a short paragraph, describe the action you feel should be taken based on the statistical results above. Well, because we couldn't reject the null hypothesis, it means that there wasn't a significant difference in the procedures. So they need to come up with a new way to work faster.
Yeah. Yep.
Cool. Okay, well, let's take that quiz. Okay, number 1 is true. Number 2 is true. Okay.
And then I can read. Suppose we have a set of paired data and let D plus X after minus X before. The null hypothesis is 0.
Yeah, the difference is 0.
Alternative, difference 0, right. The alternative hypothesis is difference is not 0, and is different. Standard deviation is not known. Jordan collects a sample of size 9, like 9 sample, and compared differences, like the mean of the different, the sample mean is
the difference mean.
The difference mean is 2.2, and the standard difference is 3.3. What is the value of the test statistic?
So we're gonna go. We go 2.2 over 3.3 over the square root of 9.
Yeah, it's the same formula, right? So how is the formula? T is equals.
I think it's T equals the sample
The sample
over the standard deviation over the square root of the sample.
right.
I think.
Yeah, exactly. So 2.2 minus 3.3. What is this, guys? Zero. I think it's 2.2. Is equals to?
That's what I got. Yeah, that's what I got.
Okay, 2. I think. And then the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine value for Jordan's hypothesis test.
Determine the p-value for Jordan's.
So we use the applet, right?
I think so, but I'm not sure where to plug that in.
So the degrees of freedom needs to be 8.
Right.
And zero point. So I think we need to use the other formula. P-value.
Or do we do 0.0403 and both of them?
I don't know. This is different to what we are doing. Its value, yeah.
So because it's saying that so it says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. So that means that if you go to the probability applet, it's just the right side.
The
right? And so to find the actual p-value, you would have to shade in both sides. Because it's positive. No, that's not true. Hold on. Maybe it's 0.0403. That makes it even smaller. Maybe. Actually, I don't know how to find that.
I am checking in the book.
Yeah.
So first we need to give the test statistic and its value, and then we need to have the state. We need to state the degrees of freedom that in this case is 8.
Right.
And then find the p-value and comparing the level of significance. T under the curve. Just say for 2 minutes. So in the book, so they use the Z-score that we get and the degrees of freedom, I think. I'm going to do that. So we get 2, right?
Right.
And the degrees of freedom are 8. So it's 0.0403.
Yeah, so that's what it says, that's what we're supposed to get. So then use this probability to determine the p-value for Jordan's hypothesis test.
The p-value? That is the p-value, right?
Right. So the probability of obtaining... Oh, so maybe it's just the other side too. Because the probability is whether it's on both sides.
Oh, so it's 0.0805.
I think it might be. Does that make sense?
See, yeah.
Okay, cool.
Yeah. 0.0805. So because the p-value is always like both sides, right?
Right.
It's not only...
It's not just greater or less than.
Okay. And then use the data file, chapter 12 data, okay, to answer the next 6 questions. Perform a paired sample t-test in SPSS. Be sure that the test is group 1 minus group 2. Use a null hypothesis of different 0 and alternative hypothesis different 0 and level of significance 0.10.
0.10 is what?
Like sigma in this case is 0.1.
Okay, so it's a 90% confidence.
Uh-huh.
Are you guys on the quiz, or are you guys still doing homework?
We're on the quiz now.
Bishop.
So I can just fill you in. I can fill you in on everything.
Cool. I was supposed to meet with Bishop tonight at 8 o'clock, so I went down to the church and no one was there at 8. Like all the lights were off and everything, so I came home and that's when I got on, and then they knocked on the door. So I wasn't expecting that.
Yeah. So Daniela, when you put it into the Excel sheet, variable 1 is supposed to be the pre-test, right?
Yeah.
Okay.
I'm...
And the n is 20, right?
20?
N equals 20?
Oh, yeah.
Okay. So...
Okay. Wait.
What question are you guys on?
We're on question... One second.
This is a long
I don't even know.
one.
I was looking at we're on question 5.
Uh-oh.
Okay, I have it right here, so I'll screen mirror so you can see mine.
Mm-hmm.
Okay. So I plugged in all the numbers over here. Can you guys see it?
Yeah.
Can you see? Okay, so I plugged in the numbers here, and it says that the t is 0.407.
Mm-hmm.
So for question 5, I think that's asking what is the test statistic? I think isn't that 0.407?
Yeah.
Or is the test statistic the mean of the differences?
No, I think it's T only.
Okay, cool.
What is again? I'm sorry.
Okay, then what is the p-value? My p-value was 0.689.
Mm-hmm. Mine is.
Do you have the same numbers, Daniela?
Yeah, T is minus 0.407 and p-value is 0.688.
Yeah, and then you round it to 689.
89. Mm-hmm.
Negative 0.407? Is that what you said for 5?
I think it's just regular point. Yeah, it's just 0.407, not negative.
Not there, yeah.
And then 7, what is the correct decision based on this evidence? Well, p is not less than 0.1. So we fail to reject the null.
Yeah.
Suppose your alternative hypothesis is instead. Oh, shoot. I need to make sure that my question is right.
It's right.
Okay. Because we just put not equal to for the type of test.
Mm-hmm.
And
Yeah,
so now we're doing greater than.
Mm-hmm.
It's still not going to get rid of it because it makes the p-value 0.34.
So you have insufficient evidence?
Yeah, because our n is pretty small.
Yeah. So
we have insufficient evidence that the difference is equal to 0. Not necessarily, because we still can't prove the null hypothesis wrong.
I think it's the second one. We have insufficient evidence that the mean of the difference is greater than 0.
Yeah. Yeah, because we can't reject the null.
Mm-hmm.
Okay, so then it's a new set of data. And I'll just plug those right back in. And what's our null hypothesis?
We're going to.
The null hypothesis is that the mean of D equals 0.
Yeah. Yeah, so it's then the alternative is, or we're testing is that it's not equal to 0.
Yeah.
Okay. And then so that the mean with a D by it is talking about the difference between two samples.
Okay.
Like the mean difference of all the samples. Because like you take a test of 10 people beforehand and you take their scores, and then you do something and then you take the same 10 and you do their scores again, and then you take the difference between the two.
Okay.
And then you add those up together and find the mean of the difference.
Mm-hmm.
And so when you say that, when you're talking about the null hypothesis, you're starting with absolutely 0 because it's I mean, there's no difference. You can't find a difference.
Uh-huh.
Yeah.
And then your alternative, you want to find a difference.
Exactly.
So when you
and then
when you run the numbers again, you want to see something different. Or
right.
You don't want that, but you might see that.
Right. Okay, so then our significance is 99%, or our confidence level. If our significance is 0.01, we have to go confidence of 0.99. Ooh, so we'll reject it.
Now, which Excel thing are you guys using for these?
So if you go to the quantitative inference procedures, and then if you look at the bottom, there's tabs.
Oh, okay.
We're on the paired sample t-test. Took me a while to find it too.
I
Excel file.
What did you get for 9, Daniela?
The t statistic is -3.737.
Right. It's so I have my difference is just regular 3.737.
3.737, nor minus?
And so I think it's because I put.
Are you in paired sample?
So look at. I'm gonna screen mirror and tell me if my numbers are in the same spot as yours. Yeah. So let me get to it. So when you look over here, it says variable 1.
Yeah.
And you have yours in the same spot?
Yeah.
Or do you have this?
No, yeah, it's the same.
Okay, then how did you get negative? Because see, mine says positive 3.73.
I think it's because I don't know if the difference, but I am subtract the variable 1 minus the variable 2 minus the variable 1. So I don't know if it's that the difference.
Right. Did you just plug it in here, or did you do it yourself?
No, I just copy and paste.
Right. So I don't understand why it would be different. Because it's like here it says, oh, it's not showing me the differences. Because like, so look at, so where mine says right here, the difference is 39. Does yours say negative 39?
Yeah.
Yeah, so I don't know why mine is that way and yours is not.
Can you click on 39, please? Look, let me check. Mine is different because it's only subtract B5 less minus A5.
Yeah, so yours says B5 minus A5. Mine says right here A5 minus B5.
No, it's B5 minus A5.
Right, and right here, if you see on mine, it says right here A5 minus B5.
Maybe.
And I don't know why it's doing that.
On mine, my first 5 columns, like, it didn't make a difference. There's no difference. It starts at 11.
Oh. Wish I could get out of that.
What did you get, Andrew?
Oh, it didn't do the math for the difference column. From 5 to 11, it didn't do the differences, so I'll have to do them by myself.
Huh.
I don't know why, but maybe you are right because Eric, you only copy and paste. Maybe mine is wrong because first I always subtract and then only copy and paste.
Wait, it's 99% confidence level, right? 0.99.
Right.
Do you guys have confidence intervals of 2.898 and 21.011?
Yeah.
P-value is 0.0012153112.
Yeah.
A DF of 21 and a T of 3.737.
So you got 3.7372.
Yeah.
So yeah, it's mine. Right.
Okay, so then it says though, so question 9, which is greater, the N or the DF? What is DF? Degrees of freedom.
Degrees of freedom. So n.
N is greater.
Yeah, because degrees of freedom is always 1 minus that. What is the p-value? Was it 0.001?
Yeah. It is.
Yeah.
Yeah, 0.001.
Okay.
So we can reject it.
Yeah, we can.
Reject that.
Okay, you decide to try another alternative hypothesis. This time you use the alternative is greater than 0, so let's change that.
Ooh.
And we still can reject it.
0.0006.
So it decreased.
Decrease. Yeah.
What decision do you make? Reject it.
You know what? This one had a lot of questions, but they're going fast. Look at that.
Based on your response from the previous question, what conclusion do you draw? We have sufficient evidence that there is no mean difference between the two groups. No. We have sufficient evidence that there is no mean difference. We have insufficient. No. We have sufficient evidence that there is a mean difference between the two groups. Yes.
Winner.
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
I don't think there's enough information to do that.
Yeah, because like the greater and less than are going to be
Greater or less than, depending on what numbers you have and what you're trying to find out.
yeah. But then if you use just is not equal to, you get the probabilities from both less and greater. So that's for sure not it.
Mm-hmm.
But then we can't know for sure between the less than.
You can just try it. Switch NR1 sample, switch the greater than to less than.
Okay, I will do it.
Less
So
than.
when it's greater than, it's
way up.
Oh, weird.
Everybody
Okay,
is
so
pointing
greater
at
than. Greater than.
So it's greater than?
Yeah, is that just in this example though?
Probably not.
I'm gonna say greater than.
Yeah.
Well, if it's less than, you have the number all the way to 0. If it's greater than,
Right.
you have the number all the way through infinity.
Right. And if you look at the p-value, so if you go switch it from less than to greater than, you have 1 minus the other one equals the other one.
Mm-hmm.
So like 1 minus the greater than p-value is the less than p-value.
Yeah. That makes sense.
So it's the last one?
Yeah. Okay. So yeah, it was the difference is greater than 0. And then because that gives you the smallest yeah. Okay.
Yeah.
What is the point estimate for this 95% confidence interval? The point estimate. The point estimate is our mean difference, right?
Yeah.
Like the number that we use to find our t-value. Because we go like 11.955, which is the mean difference.
Mm-hmm.
We go that divided by our standard deviation of 15.003 divided by the square root of 22, and that should give us 3.737.
3.737?
Yeah, so well, let me run those numbers real fast to be sure. So the square root of 22, and then it's 15.003 divided by that, and then it's 11.955 divided by that. Yeah, so the way that we found t, that's 3.737, was we used our mean difference and we divided it by the standard deviation over the square root of n.
So you took 11.955 and you divided it by the standard deviation.
Which is 15.003.
Uh-huh.
Uh-huh.
And then you divided that by the square root of 22.
Yeah.
Mm-hmm.
So I think that our point estimate is 11.355.
I haven't done that math.
Well, no. That's what we used.
For the
So you are
mean difference?
Yeah, 'cause I think that's what we're using.
Well, I used the app when I did all these last time, and I got them all wrong on the homework quiz.
Let me look at the book and look what point estimate.
point estimate.
I think it's in lesson 10 that it talked about point estimate.
Yeah, but I don't know why I think that it's that.
Point estimate. I think we can use the video in the preparation thing.
Uh-huh.
Because it's similar to question 12 in the preparation. So maybe there we can find like what we need to do.
So the only thing that I read about point estimators was in lesson 10. It says, we've learned about several statistics. Remember, a statistic is any number computed based on data. The sample statistics we have discussed are used to estimate population parameters, a mean, standard deviation of variance, and so on. The statistics above are called point estimators. But that's like a point estimate are those things.
Right. A point estimate is your X bar, it's your variance, it's your proportion.
So you have your sample statistic, which gives you like the mean, it gives you the standard deviation of variance.
Right.
But you also have those in the population parameter. So
right, but I think that the thing that we're using is our mean difference.
Okay. That makes sense to me. That sounds good. So what number did you get?
11.955.
So 11.955, that was the difference of the means.
Right.
Okay.
Yeah, because you can see in the data, it says that the means for group 1 was 25.591, and then the mean for variable or group 2 was 13. So you just take the difference, and that's 11.955.
And then what's the margin of error for this 95% confidence interval?
See, that's where I'm confused, because the margin of error, isn't it like t times the standard error of the mean?
The margin of error is C times.
Or isn't it just half of the confidence interval?
I think it is half of the confidence interval.
So we could go 21.011 minus 2.898 divided by 2, and that's 9.0565. I think that's it.
Those are your confidence intervals? Are you greater than, less than, or equal to, or not equal to?
I'm greater than.
And your confidence intervals are what?
2.898 and 21.011.
And your confidence level is 0.95, and your null hypothesis is 0?
Oh, my confidence is 0.99.
But we're doing 95% confidence on this one.
You're right. Okay.
I have
Okay, so it's 5.3.
Yes.
Yeah, okay, cool.
7.
So 18.6. Sorry, what was that, Daniela?
17, what is? We're in 17, right?
Uh-huh.
So it's divided by what?
Well, let me make sure I'm telling you the right thing. Yeah, so 17 is the confidence interval. So like it's from 5.303 to 18.607. So I found that. I said 18.607 minus 5.303, which is 13.304, and then it's half of that.
13, 3, 4. So is it half of what? 3, 13, 3.
Yeah, half of 13.304.
So 6.652.
Yeah, and I think the other way that you could find that is if you said, okay, my upper limit, which is 18.607, minus the mean, which is 11.955, 6.652.
Yep.
So those are the two ways. Those are the two ways I think you can find it.
Do the upper minus 3.
Yeah.
The lower is 5.303.
5.303. Okay.
And the upper is
18.607. All right, I'll submit it. I don't think you have everything, Andrew.
I missed 3 and 4.
Okay.
The last one is 8. What?
18.303. 18.607. I lied.
Well, we missed question 15. So I think it's not enough information.
15?
Yeah.
Okay, I can try that one.
Yeah.
Now it's the only one?
You need 3 and 4, right?
Yeah.
Okay, so 3 is just 2.
Okay.
And then 4 is 0.0805.
0.0805.
Yeah.
Yeah.
0.0805. That's not rounded to 3 decimals.
But it took it, so whatever.
Okay. Uh, 15 was not enough information.
Yeah, so can you read me those numbers?
Yeah.
I want to get those points because they're easy and I don't want to.
I have in my screen, I think, if you want to copy.
Okay. Well, as I go through, do you want to just read it? Because if I get on your screen, then I can't see mine.
Okay. So 3 is 2.
Okay.
4 is 0.0805.
Okay.
5 is 0.407.
0.407.
Uh-huh. The p-value is 0.689.
Okay.
7 is fail to reject.
Okay.
7 is reject.
Oh, yeah. I don't know why always, yeah.
7 is reject.
Mm-hmm.
8 is we have insufficient. The second one?
The second one, we have insufficient evidence that the mean of the difference is greater than 0.
Uh-huh.
Okay.
9 is n.
Okay.
10 is 0.001.
Okay.
11 is fail to reject, right?
Okay.
12 is decrease.
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 Okay.
13 is reject, right?
Yes. Mm-hmm.
14 is we have the third one.
Mm-hmm.
We have sufficient evidence that there is a mean difference between the two groups.
Yeah.
Okay.
15 is not enough information.
Okay.
16 is 11.9555. No, 5. It's only 2 5.
Okay.
And 17 is 6.652.
6.652.
Uh-huh.
Okay.
And 18 is 5.303.
Okay.
And 19 is 18.607. Right?
Okay. Cool. And awesome. Thank you.
Thank you. So, yeah.
All right, guys. Till Thursday.
All right.
Thank you. Bye.
See you later.
Bye.